You're listening to Extinction Radio FM. Listen to the podcast at extinctionradio.com.
One big question I'd like to ask you, Gail, is this in any way just is it regional? Is it nationwide, or is this worldwide?
It's worldwide at this point, and there's been a lot of studies that, especially because what I'm talking about specifically, and one of the things that kills a lot of people is particulate pollution, which is a different issue. I'm talking about specifically ozone, which is a highly reactive gas, and it's formed. We don't emit it directly. It's formed from nitrous oxides, right. Reactive nitrogen. And that comes from anytime you burn something, you create reactive nitrogen because there's so much nitrogen in the air, and combustion turns it into a reactive form. So then that goes where it streams around the world, these reactive nitrogen gases. And what happens is when they combine with volatile organic compounds, which are actually released by vegetation, and also things like paint. A volatile organic compound is something you smell. So when you smell a flower, that is a volatile organic compound going into your nose in a rather pleasant way. Mm-hmm. But when they react with nitrous oxides in the atmosphere and the UV radiation catalyzes that, then you get ozone. So it's a very, very difficult subject, even for the experts, because it's constantly moving around and it's constantly changing and going in and out of reactions depending on all kinds of other influences, like how much radiation there is, what the temperature is, what other chemicals are present. So, but it's definitely global, and what they've understood is that the reactive nitrogen is traveling just like the CO2 does all around the world. So like you have emissions in Asia go across the Pacific, come to California, meet up with the volatile organic compounds, and they make ozone. And then there are other sources as well. Methane is also an ozone precursor, and so we've had the fracking with unmeasured amounts of methane coming from that. And of course, there's methane coming from other anthropogenic sources, and also it's being released, as we know, by all the melting of the permafrost. So that's another ozone precursor. So it's coming from a lot of places. And I think it's safe to say that even the expert scientists don't have a really good handle on how much there is and where it is. And there's also a million different ways of measuring it, none of which is very satisfactory. And so one reason you'll hear people say, oh, ozone isn't a problem anymore because we've reduced it. That's only if you measure the peak levels of ozone, which have been reduced in most places, because that's one way of measuring it, is measuring it the highest it gets at certain times of the day, on certain days of the year, and averaging them out. That's very different than the perpetual background level, which has more than doubled since pre-industrial times, just like CO2.
I'm now accepting